many of these questions are going to be on the quiz tomorrow. So many of these questions we already did on the class opener. Let's take a look at number 6. So we have the fourth root of all that. What's the first thing that we would do? Split it up, right? So you have the fourth root of 64. You have the fourth root of a to the fourth. You have the fourth root of b to the fourth. Okay? 64, let's think about that. 64. I'm just going to go with the base 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So I really have 2 to the 6th instead of 64. 2 to the 6th power. So I have the fourth root of 2 to the 6th power. Now, this guy is easy. The fourth root of a to the fourth, that's just a, right? This is easy. The fourth root of b to the fourth, that's just b, right? Now, if you don't really understand that, if you were to write it as a rational exponent, if you were to take this guy and say, okay, b to the fourth power over root, the root is 4, so b to the 4 fourths, that becomes just b, right? So I hope we all see how we get this becoming a and this becoming b. Anyway, let's work on this guy right here. So we're going to have 2 to the what power? 6/4 power. So I'm going to have 2 to the 6/4 power. And 2 to the 6/4 power is an improper fraction. I want to change it. Actually, we could reduce it, right? Let's reduce first. Makes it even easier. So instead of 6/4, if I reduce by 2, I'll have 3 halves. So I really have 2 to the 3 halves power. And now let's change that improper fraction into a mixed fraction. 2 to the 3 halves. What does it become? 2 to the what? 2 to the 1 1/2. Now, the way it goes, it's really easy. You just write the base 2 times. 2 down there, 2 right there. And this whole number on the mixed fraction is going to go out right here as a power. And this fraction is going to go as a power over here on the second one. That's what I mean by using reverse rule 1 of exponents. So what do we really have left? Let's write our answer here. It's really 2. I got it from here. 2 to the 1, that's 2. Let me write down the nice beautiful a right here. Let me write down the nice beautiful b right there. 2ab. And what about this guy? What is this guy really? You don't want to leave it as a rational exponent. You want to change it back to a radical. What's it going to be? The square root of 2. Why square root? Because it's the power of 1/2. So your final answer is this: 2ab square root of 2. 9 and 10, these were actually not addressed in the class opener, but it's very important to know that you cannot have a radical in the denominator. So let's start with number 9 here. You have negative square root of 3 over 7. I'm going to split the root and make it negative square root of 3 over square root of 7. Split the root. Now, that's fine, but I cannot leave a radical in the denominator, so I'm going to have to multiply by that same radical value, because the square root of 7 times the square root of 7 will give you just 7. Now, maybe it's a good idea to mention this. The square root of 7 is really 7 to the 1/2 power. And when you multiply it by the 7 to the 1/2 power again, the square root of 7 again, what ends up happening is you end up adding the exponents. What's 1/2 plus 1/2? 7 to the 1, it's just 7. So that's why, that's the true explanation of why the square root of 7 times the square root of 7 ends up being just 7. Now, of course, I need to also multiply the top by the square root of 7. Whatever you do to the bottom, you must do to the top. And on the top, the radicals, you could multiply them together, put them underneath the same radical, and that'll give you the square root of 21. And of course, there's the minus sign that we need to put in front of our answer. And that's our answer right there, the square root of 21 over 7 with a negative in front of your fraction. Now, of course, you're supposed to look at 21 right here and see if you could break it down with multiplication so you could continue simplifying. You can't do that, you're done. Let's move on. Number 10, a lot more interesting. Number 10 is a lot more interesting because it's a third root, not a square root. So let's think about this. I'm going to split the third root. I'm going to have the third root of 2 up on top, and I'm going to have the third root of 9 on the bottom. I cannot have, so up on top, the third root of 2, you can't do anything with it. On the bottom, the third root of 9, let's change it. Let's first change that 9, and let's make it look like a 3 squared, just to have an exponent there. So I really have the third root of 3 squared, okay, instead of the third root of 9. And now let me change it to a rational exponent. So on the bottom, I'll have 3 to the power over root. That would be 2/3 power. And on top, we're still going to leave it the third root of 2. Let me actually rewrite that down here. So I rewrote it down here. I have the third root of 2 on top, and the third root of 9, I changed it to 3 to the 2/3 power. How did I do that? The 9 became 3 squared, and then I changed it to the base 3 with the power over the root 2/3. So now if I want to get rid of the radical in the denominator, I'm going to have to multiply by 3 to what? 3 to the 1/3 power. That way, when you add your exponent 2/3 with the exponent 1/3, you get the 3/3, which makes it a whole 1, right? So 3 to the 1 on the bottom. So I'm going to multiply both top and bottom by 3 to the 1/3. So on the bottom, we said we're going to end up with just 3, because 2/3 plus 1/3 is 3/3, and that's just 1 whole. So that's just going to be 3. You don't even need that power of 1. On the top, you really have the third root of 2 times, now this, you might as well look at it as the third root of 3. The third root of 3. So I really have, let me rewrite it, the third root of 2 times the third root of 3, and we could actually multiply those guys together and get our final answer, which is the third root of 6 over 3. Boom. Jumping to number 11, let's split the roots. We have the square root of 2g to the third over the square root of 5z. So we're going to have to multiply both top and bottom by what? Square root of 5z. Now you couldn't do this if it was a third root. You'd have to think of rational exponents. So top and bottom by 5z. So on top, I'm going to end up with 2 times 5 is 10 inside the square root g to the third times z. And on the bottom, I just end up with 5z. No more square root. Now, it'd be nice if we could leave our answer like that, but there's still something else we could do. Let's take that numerator and split it. So if you just pretend this was its own problem, if you ignore the 5z because there's nothing to do with 5z, pretend that that's the only problem you have. You're going to split the root. You're going to have the square root of 10. You're going to have the square root of g to the third and the square root of z when you split the root, right? Now, out of those 3, now it's still over 5z. Out of those 3, the only thing you could actually do is the g to the third, the square root of g to the third. So let me do this over here on the side. The square root of g to the third is really going to become g to the 3/2, power over root. And g to the 3/2 is really g to the 1 1/2 power. Okay? And now we know that we take that mixed fraction and split it into 2 bases, g to the 1 times g to the half. Now what does g to the 1 times g to the half really mean? It means g square root of g. That's what it means. G to the 1 times g to the half. That really means g times square root of g. Does that make sense? So I'm going to take this guy and replace this guy with it. So I'm going to have the square root of 10 times g square root of g times square root of z over 5z. And now what I'm going to do is just rearrange everything. When you say the radical times the radical times the radical, you're going to end up, well, first of all, I'll start with the g that's on the outside, g on the outside, and then the square root, you're going to have 10gz. In the square root 10gz. Because 10 is in there, g is in there, z is in there. The g is on the outside, and it's over 5z. That's your final answer for that one.